Hello, we are working on section 1214 today, all about limits. So we're going to introduce limits, maybe a topic that you don't have a lot of experience with. So we'll look a little bit at the notation and then also how to estimate limits. So get those calculators ready. We're going to be using them today. Also, if you'd prefer, you can work with Desmos on your Chromebook or whatever your laptop, whatever device you're using. The homework for today will be Delta Math, so you will need to log into Delta Math and create a class. I will have a video on how to do that as well. All right, so we are going to look at the function x cubed minus 1 over x minus 1, where x does not equal 1 since that's not in the domain of our function. Look at the graph to the right. What is f of x approaching when x gets close to 1 or approaches 1? So this is the start of the idea of a limit. And whoops, let's get a picture here. All right, I got a pen. So here is my x value of 1, correct? And that would be this vertical line. I think my picture is going to be in the way on this one. Can I move this? Let me unlock that so I can move that over. All right, so here is our x equals 1 position. And they want to know what is f of x. So the curve, the red curve is f of x, approaching as x approaches 1. So really what y value? I want you to take your pen and I want you to draw two arrows. We're going to follow f of x from the left side and approaching x equals 1, my vertical line that I've got kind of with gold right now. And then also from the right side, it's coming into this. So what height is that? What y value is that? Well, it looks like it's a y value of 3. It looks like it's a y value of 3, doesn't it? If you want to put that in there, the y value equals 3. Use your fingers to trace along. Often I need to go from the left side and the right side. A limit is this definition of the value that you approach from the left and the right. It doesn't necessarily care what the exact value is when I put in 1, but what happens as I get close to x equals 1. So we come together and they come together fairly close. The question can be written in this way. So here's the correct mathematical notation for this. The limit as x approaches 1, that's what that means. And then it gives the function. It could have also said the limit as x approaches 1 of f of x is equal, because f of x has been defined. And I could go back and substitute and look what was f of x and substitute it in there, and I would have the same exact thing, is equal to 3. Okay? So graphical limits are pretty nice. They're easy. We read from the left and the right. We will be doing more practice on that as we go through this unit 1. We also can find the limit numerically, and we can use tables of values to help us out on that. So complete the table of value below for the function given above, that f of x one, and round all the decimals to 3 places. If you want, you can use Desmos. If you would rather, you could use TI-84. Now, I think you're familiar with your TI-84, so let's just quickly go over how would you do this. Well, we're going to put our function in. Maybe we'll go over them both. We're going to put our function in. If you have the newer version of a TI-84, like one of the skinnier ones, the color ones, you have some quick keys that can get you a fraction very quickly. And you're like, how did she do that? All I did was hit alpha x, and it generates a fraction. Another way you can generate a fraction is alpha window. How about alpha y equals? And then option 1 is numerator over denominator. So anyhow, we got our fraction generated. Then I want to go x raised to the third, bounce over, minus 1, down below. So move your use your cursor to get you down below x minus 1, and we have it logged in. Then I want to go to table. Problem when I go to table, these are not the values that I need to use. So I need to be able to generate my own. Nor is there much of a pattern there. So Well, there is a pattern, but it's not something I can mathematically describe and have it fill auto for me. So I'm going to go to second window, which gets me to the table set. And I'm going to override the autofill of the independent X variable and switch it over to ask. I'm sure you're familiar with this because I bet you had to do it in pre-calc. So now I can put in my own values. I can put in 0.9, enter. I can put in 0.99. I can put in 0.999, right? Now, what I noticed on my first one is I had a fraction come up on that one. And I really would probably prefer to have decimals filling this because it's going to be a little bit more meaningful to me, a little bit more, it'll make it easier for me to understand what the true value of that fraction is. Well, I guess it's divided by 100, not too hard, 2.71. If it were harder, I might decide to change my format, not my format, my mode, and switch this, there is a spot where you can switch it to always decimal. And for some reason, I am not seeing it right now on my screen. Is it in mode or is it in format? It's definitely not in format. It's got to be in mode. And I'm just, oops, just not seeing it, guys. What the heck? Second, oh. Doesn't require a second key, duh. Oh, there it is. Under answers, I can switch this to decimal. Now I'm going to switch back to my table. And there I get all decimal answers, okay? So that's how you can control that. Go ahead and finish off the table if you liked using your calculator. The other option we have is we could go to Desmos and do it that way. I've got a quick key to get me over to Desmos. Let me bop into my Desmos screen. So on Desmos, there we go. I have my function keyed in, right? I want to go to Desmos, calculator, and then I have the screen where I can key in my function. I just went ahead and keyed f of x equals and got that. I'm going to take off my table right now so you can see it that way. Now, how do you get a table on Desmos? You can, I believe that you hit the settings tool and you're going to see a table pop up. So I'm going to say convert to table. And now this table, we can tell it's linked to our actual function because I got f of x. The values aren't quite what I want, so I'm just going to override those. I'm going to put in 0.9. I'm going to put in 0.99, right? And there's a pattern to this. 0.999. Then I'm going to put in 1, 1.001. 1.01, 1.1. Okay, so you can do that. I have very nice values here. And so take those values and plug them into our notes. Okay, and we can see off of this that as x approaches 1, right here, we do get that height of 3. Very obvious from the table of values. Okay, back over to our screen here. So you're going to fill in those values with either your TI-84 or your Desmos, and we see the same thing from the table of values that we did when we looked at the graphic screen on this one, that our answer turns out to be 3 as we get closer and closer to 1, either from the left side of it, like 0.999, or from the right side of it, 1.001. We were coming into 3. All right, switching over to the back side. Another activity, this one is graphing the following function. X to the third plus 4 raised to the second minus x to the sixth over x cubed. Now, did your mind race to, it's kind of cool how our math minds work, right? What my math mind went to right away is like, if I squared x to the third, I would have power to a power to have x to the third raised to the second. That would be like an x to the sixth. So in my brain, I was kind of comparing and saying, well, I've kind of got an x to the sixth minus an x to the sixth. Granted, there's lots of stuff in between there, right? Because if I square this out, well, I'll get a few more terms. Not a ton of more, but a few more. So just kind of nice to confirm that, you know what, that's the way other people think too. You aren't strange, you're just a math nerd, and that's a wonderful thing. All right, so it says graph the following using Desmos from either your laptop or Chromebook, whatever you have. Take a closer look at the behavior of the function when x becomes very large. Change your x-axis window to maybe go 0 to 100,000, and you might want to step it by 1,000 so that you get tick marks at 1,000, 2,000, 3,000, and that will help create a nicer x-axis to look at. To get an even better look, you may want to change your y-axis between 7 and 9 because we're going to be seeing something come out around there. There is some erratic behavior going on here. What do you predict this limit will be? So as I head off to infinity, so we talked about end behavior, or we do talk about end behavior when you're in pre-calc. So here, out here is where x is approaching infinity. What's our graph doing? Is it settling into a y value? Or is it just kind of going woo and heading off to infinity, right? That's kind of the choice. Does it settle in? Does it have a horizontal asymptote? So we're looking at end behavior. I know that because it says x is going to infinity. Add a table to your calculator and confirm the results. So whether you want to use Desmos or your calculator, you're going to fill this in. So go to your calculator, load up your function. I'm going to go ahead and clear this and set up my new function. I'm going to create a fraction right away. So I go alpha x and I've got my fraction designed and I can key it in. Put all this in, okay? So go ahead and hit pause and do that. Come back. Now we're back. I'm going to take us over to Desmos because I have that kind of set up. So in my Desmos, I should have this function. And wrong one. Here is my function. I'm going to generate a table very quickly. And I need, let's see, steps by 10, powers of 10, doesn't it? 1, 10, 100, 1,000, 10,000. It's looking very, very normal right now. It's doing a nice job. 100,000. Oh, wow, look at what we got there. That is undefined at 100,000. And would we go to 1,000,000 next? 1, 2, 3, 4, 5, 6 zeros. Ooh, it jumped to 147. That's interesting. 10 million. Whew, this is weird. Oh, what is it doing? So if I look at this, I'm trying to think, early on, I was really comfortable with the 8 for an answer. But then as I got larger, it started confusing me. And I think this problem is in here precisely because we can't always trust our calculator. This number is getting so big when I put in 1,000,000 qubit, right? And then square that as well. It's probably getting out of hand for the calculator to be able to handle. So I've kind of got this graphed out. The answer is 8, but this problem is in there just to be aware that, we can't always trust our calculator. We have to do a little bit of thinking. And later on in this chapter, we will learn how to look at some of these behaviors from a little bit different lens than just trusting a table of values where we pop in 4 or 5 values, okay? That's about all on that right now. So you're going to have, let me flip over to our SMART. What is the limit? The limit actually is 8 on this one. And we'll look in section 1.15, which is near the end of unit 1. There's 16 sections to this Unit 1, you're going to reevaluate this again. All right, so your homework is on Delta Math. You will need to enroll in Delta Math in order to do this, and you'll have to get into the right hour. I'll have all 3 hours of AB set up, so we'll get you into the proper one. You're doing limits from a table, so you're going to be reading the table and answering questions. So it is much like WebAssign that you did last year, except Delta Math has a really nice AP Calculus library of questions. All right, have a great day.